Last video in section 11.2 on quadratic formula, this is example number 4, gives us a little bit of function notation. It says that f of x is x plus 5 and g of x is 3 over x minus 5. Find all x's for which g of x is equal to f of x. So we want to take these two functions and we want to set them equal to each other. All right, but now we need to solve for x. You notice, well, you could actually do this a couple different ways. You might notice that I have two fractions set equal to each other, a proportion, and you can solve it by cross multiplying. Or you might have thought, well, I have a rational equation and I need to get a common denominator. So if I need to get a common denominator, I know that the right fraction needs an x minus 5. He needs an x minus 5 on the bottom and the top to keep them balanced. As soon as my denominators are the same, I have an x minus 5 in both of them, right? As long as my denominators are the same, then my numerators should be equal as well, right? So as soon as my denominators are equal, all I have to do is then worry about my numerators and I can solve for x, as long as x isn't going to give me a 0 in that denominator. So we need to worry about what? X equals 5? Okay. So now I have the new equation, just looking at my numerators, that 3 equals x plus 5 times x minus 5. I'm going to go ahead and solve this by getting rid of those parentheses. Be careful not to call this a perfect square. It's not. It's not the same thing twice, so you can't call it something squared. But what I can do is I can FOIL that. When I FOIL that right side, I ended up with an x squared minus 5x plus 5x minus 25. Excuse me. You notice that the two middle terms cancel, and I end up with 3 equals x squared minus 25. Now look at this quadratic equation. It's quadratic, has an x squared in it. I know I should have two answers. But you notice that there's no x term, there's only an x squared term? Well, if there's only an x squared term, then I should be able to get everything away from that x squared and then use my principles of square roots and be able to square root both sides, right? Instead of trying to factor or use quadratic formula. So let's go ahead and do that. Let's add 25 to both sides to get it away from that x squared. And let's square root now to get rid of that square. Now remember, anytime I square a square root, the square and the square root cancel. But what do I need to make sure that I add? Plus or minus, right? So I can say that x equals, and then you notice that I broke down the square root of 28. I can say that x equals plus or minus 2 rad 7. That's my two solutions. I knew that they were both going to work. Because it wasn't going to cause a 0 in my denominator because I was only worried about x equals 5. And I didn't have to use quadratic formula or completing the square. Because it only had an x squared, I can use my principles of square roots to get that x squared by itself and then square root both sides.